We've all seen it. You tap a button in a project management app, and the screen instantly updates. A task goes from in progress to done, shifting to a vibrant green. It feels immediate. It feels real. But that immediate visual change is an illusion. What you are seeing is merely a temporary front-end state. The core system, the actual database sitting on a server miles away, hasn't actually registered the change yet. If we look beneath that clean interface, we find a complex web of subsystems. You have a local cache holding recent data, a search index organizing keywords, and an analytics engine tracking user behavior. And for a brief window, all of them are holding different, outdated versions of that exact same task. When these internal systems disagree, things break down rapidly. A manager pulls a reporting dashboard and sees the task still open. A teammate searches for completed items, and the task doesn't appear. Different users are looking at the exact same software, but experiencing completely different realities. This introduces a massive architectural problem. In an application handling millions of operations a minute, with data constantly moving between browsers, servers, and background workers, the system has to know which version to trust. Software requires a single authoritative source of truth. Without a defined hierarchy of what data wins in a conflict, your application stops being a reliable tool and becomes an engine for organized confusion. Think of your software like a physical identity system. At the very center, there is a master government registry. This registry is the ultimate, unchangeable bedrock of physical identity records. In your daily life, you don't carry the master registry. You carry a photocopied ID or a plastic wallet card. These copies are incredibly convenient for quick transactions, but they are legally secondary. If your wallet card says one thing and the master registry says another, the registry wins. In software architecture, the primary database sits at the base. It's the unshakable master registry where definitive state lives. Above it, the local cache provides a temporary high-speed layer. Finally, the search index reorganizes information for quick lookups, but neither are the authoritative record. Storing the same business fact across these different layers is a strategy known as intentional data duplication, or denormalization. Denormalization deliberately adds redundant data copies to an optimized system to drastically improve read performance. Engineers do this on purpose. But there is a strict difference between intentional denormalization and bad duplication. Bad duplication happens when the exact same business fact is lazily stored across multiple unlinked tables with no clear update rules. When one copy changes, the others silently drift out of sync. Spreading data across fast caches and wide search indexes is only safe under one condition. Every single copied layer must explicitly defer back to the primary database the exact moment a conflict arises. To enforce this rule, architects rely on data ownership. Every specific metric, fact, or state in a system must be legally owned by exactly one module. That module is the only one allowed to write or modify the data. Take an online store like Amazon. The warehouse inventory system strictly owns the stock numbers. The storefront user interface can display that data, and the recommendation engine can reference it. But the warehouse system holds the sole authority to update it. If the architecture allowed a temporary storefront cache to overwrite the master warehouse inventory, the results would be disastrous. The system would inevitably sell physical products that no longer exist on the shelves. Returning to our app, the front-end interface, local cache, and search index are stalled in disagreement over a task status. The primary database steps in, broadcasting its authoritative status, forcing all other layers to instantly sync, update, and conform to the core truth. Once you establish this strict hierarchy of truth, you unlock the ability to build securely. You can cache data aggressively for speed. You can build massive search indexes safely and feed accurate information into complex AI models without the fear of breaking the application's reality. Building serious systems means looking past the surface. You don't start by asking what screens to draw first. You start by rigorously establishing what data exists, who owns it, and where the definitive truth actually lives.